Hi, this is Bernard Brault. I'm going to be making my very first gear on a CNC mill, and I just want to share with you how I'm going to do this. And of course, uh, I don't just intend to make a gear, but eventually I intend to make, I don't know, something with gears. But you got to start somewhere, so I thought I might as well start with making one gear. And I have a piece of stock here. It's made out of a Delrin, and it's about 3/4 of an inch round stock, so I'm going to use that as for the first gear. So here's the gear I'm going to be making. I'm using a CAD program called Gearotic, so Gearotic allows me to basically design gears, pinions, ratchet, and so on. So here's a gear on the left here, and you see a similar one on the right. So if you make two of them, they should actually work this way, and you can simulate how it's going to work. And as you can see now, there is a simulation active. So one of them is the I guess the root gear, and that's getting the second one to rotate. Alright, so I'll stop the simulation here. So if you get more complex model, you can see how this works. So the gear design here goes with a number of different parameters. You choose the number of teeth you want, how many, where the shaft is, and so on. So I'm not going to get into all of the details, but eventually once you're satisfied with the gear you're making, you're moving it into a project. So here's the gear inside the project, and so this is a gear I'm making, and as you can see it in 3D here. Right, so here's a 3D view of the gear and with the shaft in the middle. Right, so here's a view of it. So I'm going to be milling this using a 4th axis. So what is that? It's a rotary table that's going to be mounted on the mill, and I'll do a little video of that. So if I go to the 4th axis, here it is. And what you see up there is a drill bit. So this is a very, very small round bit. It's a 1/16 of an inch drill bit, and this is why I'm starting with the plastic, because I don't want to break my bit on aluminum yet. And I'm making like a very simple spur gear, and we'll show you the machine operation. So what you see in gray there will be the original stock, and of course the material that has to be removed is all shown right there. So the gear is made out of the machining is going to be 3 parts. The first part is to make the root. So basically this bit's going to go all the way down there and make this nice little pocket right there. The second part is to clean up the wall of the root down here. You see this is like the walls, this is the root down there, and cleaning up these walls. And finally, it's going to be to actually clean up the walls right there and opening them up. So I'll show you each operation. So if I go to routing right there, what you see in green, red, and so on are the tool paths. So if I run this simulation of the cutting, let me see here if I can move this a little bit. There you go. So now it's actually machining this, and the drill is, gradually going down further and further, and you can see that there, right? If I move it around, and it reaches the bottom, and after it's done this, if that was the only operation, it would then move on to the next gear. So the rotary table is going to turn, and it moves on to the next one. So of course that wouldn't be enough, because it wouldn't have cleaned up the walls and anything like that. So I'll show you the root wall operation by itself, and this is normally done in the second pass, and as you can see, it's moving the bit left and right. So it's cleaning up the wall here on the right there, and it's going to clean up the wall on the other side and move on to the next one. Now the tangential operation, and here's a toolpath, looks fairly complex toolpath, but you'll see it in motion, and it's basically to clean up these walls right there, and that's the final pass. So let me show you what that looks like. So it's moving, and it's going to rotate right there, and it's going back and forth, you see. So it's done this side right there, and after that it's going to move to do the other side. There you go. Okay, So I think you get the picture. So of course the machine operation I'm going to do, and then it's going to move on to the next gear. There you go. Now it's moving on to the next gear. So and it's following these red rapid motions. So of course what I'm going to do here is enable all three, and it looks like a very complex path. And if I show you the simulation here and accelerate this quite a bit, so now it's straightening up the walls, the tangential shaving I showed you last, and then it's going to move on to the next tooth. Next tooth, I should say. There you have it. So before I actually post the G code here, that's going to drive the machine operation, I need to make sure that the speed, the feed, the down pass, and there's a number of different machining parameters that you have to set right. Otherwise, if this is actually going at that particular speed right there, and you don't have the proper RPM, the proper feed speed, and rotation speed, and so on, well, it's just going to break the bit, and it's just not going to work, right? So you got to be very, very careful about this, and we'll see if we're going to get a gear out of it. All right.